and gentlemen, our next speaker is definitely no stranger at AEK. In fact, he participated in a cover interview of the Automobile Elektronik magazine more than 13 years ago. And well, back then he talked about a really exciting fact, a topic that a few believed in that time: the rise of Indian tech companies in the automotive space. Well, and today that belief has become a billion-dollar reality, right? Today he's back here on stage with a topic that's just as bold as timely: transforming the future of SDV with generative AI. Can't wait to welcome him on stage. Sable, Chief Technology Officer and Board Member of KPIT Technologies.
I get tempted to repeat the joke again, so I'll do that because I repeated it. I did it first in a conference in US. My surname is Sable, as German would pronounce it. It's okay. The sable is actually a dark, hairy animal. So I think there is a lot of stress that we have today. I think we are in unprecedented times. We have stress in terms of consumer uptake of vehicles. We have stress in terms of EV adoption being slow. A lot of money has gone into that. We also have stress in competition, new generation companies coming up and putting pressure on the system. And to top it up, we started on a journey called SDV, and we definitely have some stress in terms of delivering to the promise that we had, right? Of course, there is a promise and there are challenges. And not dwelling too much on this slide in terms of challenges, but in ancient scripts, when the disciple actually had a lot of stress, he asked the guru, what do I do when I have stress? And the guru replied, you need to have an ability to have a mental equipoise. Equipoise would mean that you need to have an ability to detach from emotions and focus on actions. I think the time to focus on action has come for us to, basically make sure that we deliver everything that we thought was promising. Before we get into the action, I would like to just dwell on what I think has gone really a little bit wrong. I think everybody had the same objective. We want to actually take leverage of software. We want to basically make car feature rich. But the same objective got translated into a huge number of different choices on architecture. And when you make architectural choices, you do have a justification for it. There is a program that you want to pick things up from. You don't want to start from scratch. But each choice, like it brings some advantages, also brings some unique constraints. And I think all of us have to deal with, for a new architecture, completely new set of constraints. So every OEM has dealt with a different set of constraints. And I think the set of constraints have just significantly exploded so that all our total learning has not really reached to a stage where you can solve all the constraints simultaneously. Is there an answer to that? Yes, maybe. And there could be a common architecture created, but we'll take that subject for maybe 2029, 2030. So what has gone wrong right now? And if you look at software, I think the promise of software and changeability of the software has been overestimated in terms of ease. So there is a lot of underestimation in terms of integration of the software with the underlying system. And that system is definitely a constrained system. So the choices that you make doesn't really make the software work. And this is, I think, the fundamental challenge. So let's look at what we can do about it. And here I'm going to go a little bit slightly lower on altitude here. There are a couple of things that we could do, and this is not my personal opinion or a company's opinion. This is where we have experienced the best practice in at least one instance with an OEM, and which they have actually cracked. And that is what I'm going to talk about. And I generally see that there is one practice that is happening where we are helping, but that is not really happening across the board, where everybody could actually leverage things out. So let's get into the first one. This is a very, very critical, fundamental topic that has been ignored across the board, is platform validation. Platform would include the combination of the network, the SoCs, the ECUs, the middleware that goes on top of it, the operating system, the switches, and the whole, everything that has nothing to do with application but is required from a foundation perspective to be implemented very well. If the platform is weak and it is fragile, like in yesteryears, you could actually live with brute force testing and then making sure a golden sample was ready and release the golden sample and then just forget about it. Now it is not okay, because when software has a life cycle, when FOTA is going to happen, a fragile platform is going to immediately crack open and the challenges will start happening. And this is one reasonably ignored problem. So is there a possibility of doing something about it? Yes, platform validation can be done. Anywhere between 10,000 to 35,000 test cases, test scenarios, whichever way you end up calling it, can be implemented. There could be 100% automation done. This has been done already in certain cases, and that has significantly increased, maybe tenfold increase in terms of the release time, quality, speed that is required to make these releases happen. Because you have a very, very strong ability to regress the platform, and as a result, any application that you launch on that platform, if it breaks the platform, and it does break the platform so many times, you can quickly get back to the table and fix that problem. I think there is another advantage of doing platform validation. Because you have a platform, you build a regression around that, and you probably do it even before you start interacting with a hardware supplier in terms of making that happen. There is a possibility, there's a higher probability of you coming out with accurate specifications of the hardware, and then when the hardware supplier is ready with the hardware, you can actually also have a quality check in terms of whether the hardware delivered to the performance or not, because you have the platform running in terms of all the test cases that are regressing it. So I think this is a dual advantage. I have not seen many OEMs take this advantage, but the state of art exists in terms of making this happen now. The second topic that I don't see happening in many places, but in some places it's very seriously taken up, is virtual validation. And let me detail it out a little bit, because I think there is a misconception about virtual frameworks, platforms, ECUs, whatever you want to call it. Virtual, any infrastructure is not to replace the real hardware infrastructure or real bench. The framing has gone wrong. We don't want to replace the real bench with a virtual bench. But the virtual bench can still be used to verify many single ECU, multi-ECU interactions, architectural implementations, especially on the behavior side. And those could be significantly scaled up in terms of reusability across car lines, especially when you go into regression. Again, I'm repeating the word regression. Okay, when you want to do 100%, 97, 98% test automations, and when you want to scale up nightly builds, daily builds, weekly releases, I think you cannot have so many real hardware benches. And I think scaling up a virtual bench is much easy, because it's just a software scale up into the cloud. So I think the way we need to really frame virtual validation is a complementary to the platform, complementary to the benches that we have, the real benches that we have, and both have to work together to solve all the test cases that we want to actually validate. It is not there to replace the hardware bench again. And the third is again missing. Very interesting. I go across the world at all the customer sites, and I see that the subsystem bench approach is totally missing. And there are anywhere between, depending on what you call as a subsystem, there are anywhere between 7 to 15 subsystems in a modern vehicle. And if you are able to build those benches, both virtually as well as physically, you may be able to catch many of the issues early, which get actually postponed to either the lab cars or then subsequently the fleet vehicles. And again, this is an ignored area, but this is also being handled very successfully by some OEMs. So these three, I think, are real important aspects which are being missed by most of the customers. And there is a lot of the work already done. So there is expertise available, there are tools available, there is methodologies available, there is equipment available to make all of these happen. But I think there is some kind of an early effort that is required to make all of these happen. Can this be done now while the programs are midway? Yes, we've also started it doing for some of the customers now. So it definitely helps, because anything in the platform, if you actually look at a root cause that may be in the platform, will show up as a symptom in almost every single application. And then the number of issues will just keep on multiplying. And that's what you can control. I think this is one more important thing that is missing. When you go to the right-hand side of the V, first of all, most of the left-hand side, the first three boxes that I showed, those issues come to the right-hand side of the V, which is not the right thing to do. The right-hand side of the V is to validate that the system does not have a problem, whereas the left-hand side of the V is to actually find out the problems. And when you go to the right-hand side of the V and you find out the problem, there is no way of actually reproducing this problem onto the left-hand side. And I think observability on a system bench or a car fleet that is happening is extremely critical to bring back observability back onto the subsystem benches to be able to diagnose the problems and fix them. Combined all of these, if you combine all of these, I think there could be a huge amount of time, anywhere from 1.5 years to 2 years in the program. The pain that happens in the program, especially at the last stages, can be eliminated. There are some implementations happening. We are seeing the benefits of that. So I think from a summary perspective, from a validation, 4 critical areas missing: platform validation, effective use of virtual validation, unavailability of subsystem benches, and then subsequently improving on observability in the system benches as well as the vehicle fleets. If you capture these 4 areas, I think a lot of progress could be made even in the current programs to make sure that we accelerate towards the SOPs faster. I just want to take a pause here and move to the next subject. This is a slide that I created for our board, and I had to bring in a concept because there's a lot of misconception about AI. AI is like if you can imagine an analogy, you already have a bicycle to go from one place to another place. And then the standard tools of AI, like ChatGPT, like copilots, like anything that is shrink-wrapped right now, allows you to convert your tool from a bicycle to a motorcycle at best. So you do get some benefits, but eventually these benefits will be enjoyed by everybody. I think the real power of AI will be when you disrupt the existing processes. When you take a work process and you completely disrupt it, when you start questioning why there are 15 steps in this work process, why can't there be 4? Why can't I club these things? Why can't I just merge few things? Why do I need to have human intervention? Why can't AI do this? And when you actually think about such a disruption, then the real power of AI starts emerging. Okay, so just to give, what we are trying to do is we have actually enabled a workbench which can be implemented. I can talk about why a workbench is required later in the next slide, but about 5,500 people are actually using these workbenches. Close to 27 transformation workshops have happened. This is important because AI is just a tool. If you don't transform the process, nothing is going to happen. You're just going to get some marginal benefits. Then 50 odd projects. These are large projects that are going through this process at the moment, and we are seeing some phenomenal results as a result of that. And as a result, close to about 15 agents have been deployed. And this is just one small example that you're seeing on screen, where the triaging process has been automated. This is directly going from a defect that has been found. The logs are used along with the defect, and then you're able to automatically triage. The code has been organized in a form that AI understands. So the system, the AI model is able to actually predict what patches are to be made to the code. The patches are offered to the developer to supervise, and actually then subsequently it's a human decision whether the patch is correct and whether the patch can be taken up or not. So I think AI can be used, but I will start from the left-hand side. AI is garbage in, garbage out. So if the requirements are not good, you cannot expect AI to work properly. Incomplete requirements don't work very well. Can requirements be generated? Yes, definitely. Can requirements be made complete from an incomplete? Yes, it can be, but for that you require a lot of domain knowledge. The domain knowledge that is collectively available in this room has to be translated into an artifact that the LLMs understand. And those artifacts have to be in a format that can be reused time and again for multiple projects. And the ontology of that domain knowledge is going to be extremely important. So that is one part of how you can actually make the requirements better, the test cases better, by having some ontology created on the domain knowledge. On the other side, triaging also, you can create an ontology. You can create a knowledge base where triaging can be made effective. Triaging is the most bottleneck operation. Typically, when thousands of issues come up, there are only few people in the team who can actually read through the issue and even figure out where exactly this issue needs to be sent to fix it. And these are very, very precious people inside the organization, usually bottleneck, usually stress. You can scale this operation up, but for that, you need to understand how to actually push the knowledge into a system that AI needs to understand. That can be done. But we still don't solve the whole problem, because in between, you have an execution environment. And when in last maybe about 3 months or so, when multiple interactions with customers have happened, we've realized that we can accelerate the left part, we can accelerate the right part, but in the middle we get stuck. And I think in the middle also we are forming solutions now where a pipeline that actually creates a test and pipeline that actually can triage also needs to execute the test effectively. And when you actually look at a test execution environment that is highly automated, it puts a lot of pressure in terms of what the test equipment is, what the bench is, whether you are doing platform regression, whether you are doing application regression on top of that. So the whole system of putting everything together becomes a high-pressure system. So AI in isolation cannot really add significant value addition unless you build all of these things together. What's your automation strategy? What's your testing strategy? What kind of virtual bench and real bench configurations you are going to make? And as a result, then are you able to leverage the AI significantly? So this is as far as AI is concerned. To summarize, focus on the platform validation. I don't think it's late. Even if you're late in the SOP cycle at the moment, even if the programs are coming together, it always makes sense to do a platform validation cycle. There's a lot of reusability. Things could be quickly adopted to your platform and can be done. Leverage virtualization. When the time to test every build for every test case every night comes in, I think the virtual infrastructure will be very, very important to make that impact, make it happen. It's a combination of the real virtual bench as a test strategy that you would like to create. Validations have to have a KPI on automation. What I have realized that if you don't explicitly push for automation, automation does not happen. The test cases are usually manually tested. And when you do manual testing, when the time for release happens, the pressure happens, usually some of the manual test cases are skipped. That is a potential issue for a bug to come into the system. And that could be easily avoided if you automate everything. So have an KPI for automation, build regressions very, very effectively. Every build, every test, every night, if possible, has to be tested. Take a look at whether it's every night or every 3 days or every week. I think it could change with the OEM's preference, but I think it's critical to make sure that this infrastructure exists. Especially in case of AI, I would like to leave a thought. Rethink the departmental approach that you might have today. If you want to have a workflow disruption happening, you may want to empower the AI team. So what we have realized is AI is not a single technology team task. It is not a department task which is focusing on a specific domain. AI is actually a good symphony of AI specialists coming together, the process specialists coming together, the domain people coming together, and then there's some good guys who actually write Python code fast, who could actually make agents faster coming together. And if you actually merge these, then things can happen much faster. So I think please look at the organizational angle of implementation of AI significantly. And then, of course, the point that I left is question that I want to pose to the audience is there a possibility of having, if there are a set of objectives that are similar from an industry perspective, is there a possibility of converging on a single architecture that could be used in the future? Thank you very much.
Thank you very much. So let's have a Q&A. Well, we have several questions coming in, and here's one which is, well, let's say straightforward, perhaps one of the toughest, and it's a short question, but I think it hits the bottom line. You did not mention hardware costs as a problem with SDV. Why not?
For the SDV? Mm-hmm. I think SDV, one of the promises, should actually save the hardware cost. It should not increase the hardware cost. So I think we could optimize the hardware cost for an SDV. It should not increase.
Mm-hmm. It should not increase.
It should not increase.
Good news. Next question. A key question from Steve Bandley. In your opinion, why is platform validation not implemented widely? And how do you resolve this?
Yeah, I think platform validation is a difficult subject because the instrumentation that you have to do for platform validation is not a decision that could be taken on the spur of the moment. I think you have to have access to a lot of equipment that's capable of doing that. Mm-hmm. You need to have a lot of framework on top of it, libraries on top of it to enable that equipment. Mm-hmm. So all of that is not very easy to quickly get together, and that's why it is missed. It's usually a small lab where the platform actually starts getting built up earlier. Mm-hmm. And I think today's state of art, we could actually set it up very quickly.
Mm-hmm. Thank you very much. And we have another one that came with lots of votes, so it's clearly hit a nerve. When an on-road critical defect occurs, especially when a death occurs, traceability to the root cause is required. By its nature, AI does not produce algorithms and thus is not traceable or deterministic. It is designed to learn and to change continuously. So how will we handle critical defect traceability in the future? And do you think the public will feel comfortable with this solution?
Depending on which particular application you're talking about, AI can also build traceability. So if you take a requirement and look at the code that is generated out of it, you can actually build traceability as a part of that. It's possible. Depending on the application, you have to take a look. For example, you could design the architecture in such a way that some things are fault tolerant. Where there is no fault tolerance, you again need a human intervention to verify. But AI can aid that verification process also.
Thank you very much for clarifying. Next one. Could you please give some information related to the toolchain solutions? Are you using a vendor base or a self-developed toolchain? And how do you solve the integration with several tools that may be already used for requirement and test management?
So, splitting up the question in multiple, I'll take the AI angle first. In AI, currently the work is happening on open source workbenches, but the agents are built specifically for the purpose. So there is a lot of domain knowledge that goes into the agent in terms of solving a specific problem. If you look at validation and if you look at specifically on the hardware, some of the special hardware because of our sister company Technica is already there. And there are libraries to use that hardware. If you look at other investments that have already happened, yes, it can be done, but the challenge always is when you are in a stress situation and you want to actually verify the DUT, the device under test, you should not have any doubt on the existing equipment and its integration challenges. And I think there is a challenge, but it can be done.
Thank you very much. Let's try to squeeze in another one. Increasing fidelity virtual models combined with increased compute availability in the cloud is driving virtualization impact. And for now, do you have different maturity and granularity levels in your virtualization approach?
Yes, there is a multi-step. There is an L1, L2, L3, L4, L4 plus also in virtualization. So you can select different ways of doing virtualization depending on what the objective of the test is. And you can actually also create environments where these complexities can increase depending on how much you want to spend. For example, one of the testing approaches, what we have taken with one OEM is we offer him a test that focuses purely on functionality as well as system together, and functionality and system and certification together. And there could be a different way of executing these three different categories of test.
Perfect. And last but not least, we're having a short question, and I think this one reflects definitely what many in the room are wondering right now. First of all, wonderful presentation, congratulations. So how do you want to roll it out?
Pardon? What?
How do you want
to roll what
out?
What roll out?
Yes.
Roll out what?
The rope.
Sorry.
So what you talked about the last 30 minutes ago.
Okay, everything. Yeah. I think we are ready. We are already approaching the customers. A couple of things that can happen, right? I don't know if any purchase people are sitting here, but the time and material model of engagement has to significantly get disrupted here because there is outcome-based possibilities here. The innovation can happen in terms of AI. The innovation can happen in terms of the speed of execution. And I think time and material is not the right thing to do. But there are some very positive engagements happening, and customers are slowly coming on board on this.
Okay, so thank you very much. That's showing us that generative AI in automotive is definitely no longer science fiction and definitely already part of the strategy. Thank you very much. But before I let you leave the stage, I would love to have a closer look to the poll results that we have had earlier. So the question was, how important will open source be for SDVs in 2030? So let's have a look into the future and let's have a look what your answers are. So Anu, does it match your experience?
This one?
Yes.
Yes, I think open source can be made successful. There are a couple of requirements for that. We can discuss that in the coffee room.
Perfect. Good news. So thank you very much for your vision and clarity and for reminding us that AI is definitely both intelligent and international. Thank you very much.
Thank you very much. Thanks.
Thank you.